Okay. So what's P3 right here?
I mean, it's your vector space.
What's the size of this vector space? 4. So degrees at most 3, cubic, quadratic, linear. Don't forget 0 is also a number. So you're going to have your constant term. Okay. Now this is also a real good question put on an exam. Many times students will say 3 instead of 4. All right, so the set of all polynomials satisfying this characteristic. Okay, so to be a subspace, that means you got to be closed. You got to have a closure, and under addition, the scaling, and it contains the 0 vector. Now, here's my recommendation. This problem, you see how it's kind of topsy-turvy? You're not really sure which direction it's going. Just write out a vector, polynomial, something to give you the essence of the problem. All right, now, if you were to plug in 0, you're going to get D. And if you were to plug in 1, you're going to get A plus B plus C plus D. These two conditions have to be the same. So that's going to force us to be 0 in the end. Okay, so this condition implies that condition. Okay, the next one, just take a quick look at it. You have the set of polynomials in which you plug in 0, you plug in 1, you're going to get 0. Now, again, what this would entail is this is really telling you're talking about roots, because if you plug in 1, there's no way you can get 0 otherwise, but you're not really for sure which one it is. So you do have that condition right there. And the next one, the set of all polynomials with integer coefficients. So here is really 1. Here's 2. And the question is it possible not be a subspace and still maintain that property? See if you can try to break it. Try to think of, well, I don't think that's really true. Don't get locked into following the flow of the crowd and say, well, it's got to be true. Well, always question, is it really true? Now, doing that in real life, people don't like you when you do that, but that's definitely needed in our society these days, it seems like. Okay, so think about that for a moment there, Joey. I want you to think about that part. I want you to think about that part for a moment. Now, in order to be a subspace, you got to maintain closure for one. So if this is P, let's consider this Q over here. And let's just say beta, gamma, and then delta. And if you were to plug in, we'll look at the conditions. If I plugged in 0, we are going to get our delta. And if you plugged in your 1, you get the summation. Okay, so to be a space, and if I'm going to have the property that when I plug in 0, it's like if I'm plugging in 1, if it is a vector space, that would then imply that whenever I look at my summation of these two, I'm going to get the same thing. So the question is this inside that space? Does it have closure? Okay, so let's just plug in 0 and 1, and let's just see what unfolds. Okay, so once again, if I do the addition with my polynomials, it's like taking the polynomial and operating on it individually. Now, when I operate individually, I see that here I would get d and then plus delta. And when I plug in 1, once again, it's like I'm operating individually. I would get my a plus b plus c plus d, and then also alpha, beta, gamma, and delta. Now, wherever you're adding up polynomials, you add up the like terms, and this would consist of a and alpha, b and beta, c and gamma, and lastly d and delta. Okay, so we got that. And that's telling me very quickly, yeah, it looks like it's definitely be closed, maybe, because we do know that we're going to have this. And we do know also we have that. So if these two things are true again, that's telling me that a plus b plus c has to equal 0. That part right there is equal to 0. And the alpha plus beta plus gamma would have to 0 out. And the question is, does that imply that d and delta have to be the same? That's the only hint here in the end. Well, whenever you have this condition and you plug in your 0, you're only left with your d and you're only left with your delta. And if you assume that these two things are the same, those two things are definitely have to be the same. So this would definitely imply that it is closed. Okay, now, so I can get that all on one board there for you to take a little closer look at it. See if that line of logic makes sense there, Joey. Now, the next thing is you have to check to see, if you do a scaling. So if I was to maybe take a constant, multiply it by the polynomial, I'll just take that constant, I'll just push it in with all the coefficients. And if you were to plug in 0, what you're going to get out of this is k and then d. And if you're to plug in 1, what you get out of it is the summation of all your terms. Divide out the k, assuming k is not 0, it wouldn't make much sense to do this. And then you do get back to here. Okay. Now, let's just go back one more step. We do know that that is going to be true. Now, since that's true, and if you were to plug in we'll call this Q so we don't get confused. If you plug in 1 and if you plug in 0, you do get your K, you do get your D. Like that. Now, you can't really set these two things equal. This is really what sets it equal. But with this condition, you do know that right there. And if you were to factor out the K, you can apply 0, and these two things then would be the same. Okay, so that's saying, yeah, looks like 1's probably going to be true. Okay, make sense?
Yeah.
Okay. All right. Again, let's come down here and let's look at the second one. Okay, so the set of polynomials satisfying this condition. Okay, let's just kind of look at a silly example real fast. Let's say if you were to have t and t minus 1. That definitely would work. And here's another example, maybe like 2t and t minus 1. Okay, that's what that's referring to. One of them is going to be 0. I'm not really sure which one. Now, when I write it like this, though, I am lock myself in a certain thought process. What also would work is that. And this one right here would work. So there's multiple ways of how I can make this thing crank. So don't say I have to make that 0 and I have to make that 0. It's just a possibility. Okay. Let's just explore it a little bit further. If you were to take this thing, expand out, you would get your 2t minus 3t plus 2. And up here, you get your t squared minus your 3t. Okay. Now, Joey, what would happen if you took this equation and you add it to this equation? You get 2t squared minus 6t plus 2. Okay. What if you were to plug in 1? Let's just call this p of t for a second. What would you get? Minus 2. So it's definitely not going to be 0. What happens if you plug in 0?
Still get 2.
Yeah, it's 2, isn't it? Is that 0?
Quiet.
No. So if you took these, multiply them by each other, would you get 0? No. So that tells us then that, sorry, this is not closed. Now, if I limit myself to only thinking about it from that perspective and say it has to be t and t minus 1, then I'm going to fool myself very quickly because it's going to have that structure, and then I would have other pieces as well. I mean, it's a degree at most 3, so it's possible to maybe have another piece up here to get a quadratic or a cubic, but you would factor out those like terms, and that was going to maintain 0 and minus or 1 as being a root, but it's not true. So again, what you have to do in a lot of these true-false problems and with a lot of different problems in math, as well as life, I suppose, don't take things for face value. A lot of people will say, this is the way it is. Are you sure? But going against the grain like that, once again, people don't like that. But it's a skill set that really pays off because it shows you the real truth and not the perceived truth. Okay, so 1 looks like it's true. 2 looks like it's not true. What about 3?
A set of polynomials with integer coefficients.
Okay, think about how you add up polynomials. You add them by like terms. And if all my coefficients are integers, if I add up my other coefficients from my other polynomials, which is also integers, an integer plus an integer is it's closed. And if I was to scale it, if I scale a polynomial, let's just take this one. I scale it by 3, what am I going to come up with? Integer coefficients again.
Yeah.
I'll get 6, 12, and 3. So Joey, is that true then? It's not. Because once again, I force myself into a corner. I made the assumption that you have to multiply by an integer. Why not multiply it by pi? It's just got to be some constant, and pi is a constant. Is that going to maintain the fact that it's going to be integer coefficients? No. So you can see how easy it is to really trip yourself up and to think that, yeah, it's true when it's really not. So we have to kind of dig into a little bit more and question, be a scientist. Is it really, really true? So what we have here looks like 1.
Yeah.
Wow, what a problem. Good. Well, how are you feeling about it?
Good. Yeah.
Good. You see how we kind of navigated through it, looking at the
Yeah.
logic of each piece?
Right. Yeah.
Perfect. I love this problem. All right, let's take a look at the next one.
If you need anything, just let me know. You're always welcome to send me an email or to stop by during office hours. Until next time, keep up the good work and have a great day.